Hi everybody, we've got some calculator work to do today, so I'm going to try to do this so that you can see it. It's a little bit unusual, but we're going to give it a shot. So I need you to get your books out and turn to page 81. Today's lesson is really just about mathematical modeling, which is simply the fancy way of saying using math to solve problems. So we're going to start by taking a look at problem number 1 on page 81. And I'm going to show you how to let your calculator do a lot of the work. You'll notice that in number 1, they essentially gave you a table of values. A bunch of x values and a bunch of y values. Well, let's start by putting that table into our calculator. So here we go. Turn it on. Press my Stat button. Now notice that the Stat button brings up a menu. Anytime you are going to put data into the calculator, you are going to use the Edit menu. That's the first one. That's what's highlighted. We're going to use the Edit menu. Now, press Enter, and notice that my calculator already has data in there. If yours doesn't, then you just sit patiently. If yours does, then you want to clear that out. Notice that I have data in the L1 and L2 columns. So I'm going to go back to my Stat menu. And notice the fourth option down is Clear List. So I want to clear all the stuff in my calculator. So I go down there, and now the calculator is basically asking me, which lists do you want to clear? Well, I want to clear L1 and L2. And you'll notice that you have an L1 and an L2 right here. So we're going to press second L1, and then our comma, and second L2. Press Enter, and it says done. Now when I go back into my Stat menu and hit Edit, notice that my columns are both empty. You can also, using the Delete button on your calculator, physically delete each item individually. That's not such a bad idea unless you have 50 items in each column, and then that takes forever. So you do have in your Stat menu the Clear List option. Take advantage of it if you wish. Now I'm going to put some data in. Now I have empty columns. I'm going to put it in. So L1 is my x's. So I'm just going to go ahead and put those in. Just hit 3, Enter. 5, 7, 9, 12, and 15. Once I get all those in, I'm going to go ahead and put in my L2s, corresponding, match them up. So 6, 10, 14. 18, 24, 30. Okay, now we have all that in. Now we are going to draw a scatter plot of this data. So to do that, let's go to our window, and notice my window is set in the standard format like always. But in this problem, I know exactly what my x's are and exactly what my y's are. So my smallest x is 3, my biggest x is 15. So I'm going to, just so I have a little wiggle room on either side, I'm going to set mine from 0 to 20 for my x's. And then my y's, I'll set from 0 to, maybe 35. Notice there's nothing precise about that at all. I am just trying to get all my data points inside of the window. Now, to get the scatter plot drawn, I have to go up here where it says Stat Plot. Notice I put information in with the Stat button. Now I'm going to plot it, so I'm going to use the Stat Plot button. Notice that all my plots are turned off. I need to turn the first one on. So I press Enter, Off is highlighted. I want to highlight on, so I'll press enter again. And now that plot is on, and I'll press graph. Oops, I got some funky shape in there. I don't want that. Do you know why that's in there? Because I have a graph in my y equals, leftover from another day. I have that stuck in there. So I'll clear that out, and now all I have is my plot. So there is my scatter plot. Okay, now notice if you read the directions to problem number 1, which is the one we are doing on page 81, you notice that it says match the numerical model to the graphical model and the algebraic model. Now by graph they mean connect these dots. What are you going to have? The algebraic model is the equation. Now I'm going to leave it up to you. I think you can figure out it's a matching exercise. I think you can figure out which one it is. Certainly, you ought to be able to. But how do I get the equation for that? Well, your calculator, believe it or not, will do that for you also. So we'll go back to Stat. And when we want the equation, we're going to choose the Calc option. Now, did you pay attention to the shape you had when you graphed this? Let me press graph again. That looks like a line, doesn't it? Okay, so we'll go back to Stat, over to Calc, and then we're going to go down and choose the linear regression model. Now notice, right under linear regression is quadratic regression. If when you graph your picture, it has you plot your points, and it has a parabola shape, then you know you're probably looking for a quadratic regression. But ours was a line, so we're going to hit linear regression and enter. Now the calculator is saying, okay, what do you want me to do a linear regression on? Well, again, we want it to do a linear regression on L1, comma, L2. Those are the columns of data that we want it to operate on. When I press enter, notice the format of the equation is y equals ax plus b. A is 2, b is 0. So your equation for the data points that you plotted is y equals 2x. Wow, that's pretty cool, isn't it? Let's do it again. Let's take a look at problem number 8. Okay, now obviously we're going to have to make some modifications. We're going to go one step at a time. So here we go. We have to put our data in. So when we go to put data in, we go to Stat, and we choose the Edit feature. Okay? Now, just like we talked about before, now we all have data in L1, L2. I do not feel like physically deleting each entry, although I can do that. I am going to go back to Stat, click down to Clear List, L1, comma, L2. Now my list is cleared, so I'll go back to Stat and Edit, and now I'm ready to put my data in. So I am going to put in the data points in problem number 8. Please join me. And then I will put them into my second column, but my Y's go in there. Okay, press enter. All right, so I got all my data points in there. Now do not graph anything yet. You're going to have to fix your window because remember your window was adjusted for the last problem. So we need to readjust our window. This time our x's, maybe we can go from 0 to 25. And our y's, maybe we can go from 15 to, oh my, 615. All right. Now our plot is still turned on, so all we have to do is hit graph, and there we go. Now, boys and girls, take a look at that shape right there. That does not look like a line. That looks like a piece of a parabola. So to write the equation this time, I'll go back to Stat, over to Calc, and down to quadratic regression. I will tell the calculator to work on L1 and L2, and it will give me the equation. Now keep in mind, quadratic equation, ax squared plus bx plus c. This one has the answer has an a value of 1, a b value of 1, and a c value of 0. So that equation would be x squared plus x. Y equals x squared plus x. Okay? All right. Now, while we have our calculator, and you're going to get to practice some of those tonight, so hopefully that explanation helps. I would like you to take a look now at number 24, only because I want you to pay attention to the directions. It says graph a scatter plot of the data. You will have no trouble doing this. We're going to do it exactly the way you just did. You'll enter your x's in L1 and your y's in L2. Your x's will be the years, your y will be the passengers. Notice that there are 2 columns of each, so it's going to be a big table, but you can do it. What I want to point out to you is part A tells you that x is the number of years since 1991. So in other words, instead of entering x values that are 1991, 1992, and so on, they want you to enter x values that are 0, 1, 2, 3, and so on. Because if x is the number of years since 1991, then 1991's data would be 0, 452.3. 1992 would be 1, 475.1. The reason that they do that is not to complicate things, but actually to make things easier, so that your x values are much, much smaller, and the numbers in your equation then will be smaller. So you can finish that problem on your own. I'm quite confident of that. Now I have another one I'd like to look at, but we're going to step away from the calculator for a moment, because we are going to do this one by hand. Actually, you know what? Since I'm sitting here, let me go ahead and finish with the calculator, and then we'll do the by hand part in a minute. So problem number 37, it's a yicky equation, but it says solve the equation algebraically, which we will do in a minute, and graphically, which we're going to do right now. So you're looking at equation number 37. First thing I need to do is, remember when I hit stat plot and I had those dots in there plus my original graph that I had stored in my calculator? I do not want those dots to be part of my picture now. I'm done with those. So I'm going to go back to stat plot, and the plot that I had turned on, I'm going to press enter, and now I'm going to click back over to off and press enter. And now when I go to put in y equals, I won't get those dots. The data is still in my calculator. I have not cleared the list, but I won't get the picture now because I turned the plot off. So in comes my equation, x plus 1. Oh, you can't see me pressing the buttons, can you? X plus 1 minus 2 square root x plus 4, close those parentheses because I'm done square rooting, and that's it. That's the equation. Now my window, remember, is all messed up from before, so I'm going to put my window back at standard window, so negative 10 to 10, and negative 10 to 10, And just a little hint, if you care, it's no big deal for me to enter those in, but you can do it with a button. You have a zoom button right here, and if you press zoom and go down to zoom standard, it will automatically set your window for you. It also just graphed my picture for me. That's the picture of the equation that we just put into our calculator. So let me go back to my window. I put this in manually. If that's okay with you, just hit graph and you're going to get that picture. If you would like to not enter your window and you want this number by number by number, and you want the standard window, just hit zoom and go down to zoom standard, and that will do it for you. But at any rate, there's the graph. Now we need to solve that equation. You need to know how to do this. It's a part of the test you're taking tomorrow. So I think you can do it. Second calc. I need the 0. That is the x-intercept. My cursor is flashing in an amazing spot. It is left of the point I'm looking for, so I'm just going to hit enter. Now I'm going to move my cursor. So that it is to the right. Hit enter, and then I will move it down to where I think that 0 is and press enter. It says the 0 is at 5. How's that? That's a pretty cool thing for that answer to work out so nicely. In a minute, we're going to solve that equation by hand. But right now, we did it graphically. That's all we needed to do. I have one more thing I want to talk to you about, and that is this equation. Would you put this equation into your calculator? Let's clear that one out. Put this equation in. X cubed. Oh, did you see how I did that? Let me try that again. X cubed minus 1.1x squared minus 65.4x plus 229.5. I know that's a wild and wacky equation, but there's a reason for it. Get that equation in. Here it is. Okay, press enter. Graph. Now, keeping in mind that what we are looking for are the x-intercepts, we could certainly find this one over here. However, it's kind of close to the end of my screen, so I'm thinking I might want to make my screen go a little bit further to the left. So I'll adjust my window. And instead of going at -10, let's go -15. Now, that gives me a little more room to work to find that 0. So here we go. Second calc, 0. You guys have done this a million times. You better be good at it. Oh, shoot, I don't even have any idea where my cursor is. So I'm going to look here. It's where x is -2.5. All right, I need to move it. It flew by. This is one of those things where you really have to kind of be paying attention to what's on the screen. If you notice, I have a point, my cursor is sitting at the point -9.4, -86. I'm going to let it be there. I'm going to press enter. Now I'm going to move my cursor till I have a positive y value and press enter. Now I'm going to move it in between there. I never did see my cursor, you guys, but I know my 0 is at -9, 0. Now, again, let me try to explain that to you a little bit. Let me do that over again for you. Second calc, I'm just starting all over again. Now, I know that my 0, the y values to the left of it, these points are to the left of it. These points are to the right of it because the curve is moving that way. So I know that to the left of that point, the y values are negative. So I am going to move my cursor until I have a negative y value. And then I'm going to press enter. Now I'm going to move my cursor till I have a positive y value. Is this an exact science? No, you just want a positive y value, so I'll press enter. Now I need to move my cursor so it's in between those two. Press enter, and there's my 0 again. Now, so 1 0 is -9. What was the point of this problem? Well, let me show you something. The calculator, as cool as it is and as much stuff as it does, it has a deficiency. Often the curves exhibit what's called hidden behavior. I am not exactly sure what's going on right there. So here's what I'd like you to do. I'd like you to change your y values to -1 and 1. In other words, we are squishing this picture. I'm still not exactly sure what's happening there, so I'm going to change my x's. Let me go back to the picture again. That's the axis. So let's change our x's to maybe +2 and +5. I'm over a little bit too far, so I'll go back to my window. Notice, not an exact science, kids. Not an exact science. Oh, now wait a minute. Remember what that looked like before? Now it almost looks like it might be going below the x-axis. Let's change our y's to -0.1. We're making the screen very small. Oh my goodness. Let's change our x's maybe to 4 and 6. Oh my goodness gracious. Look at that picture. Here's my window. For those of you that I was talking too fast or moving the calculator around, you couldn't see. There's my window. I just narrowed things down to get in to see what exactly was happening to that curve, and this is what's happening. So when it looked before like maybe there was only 1 or maybe no zeros, there actually are 2 in there. And how would we find them? Like you always find them. Second calc, set your bounds, and go for it. You will have the opportunity to do a problem with hidden behavior. That is number 51. So what I want you to do is go ahead and graph it in a standard window, kind of get a feel for what it looks like. And then, based on what you see in number 51, make your window smaller so you can kind of blow up that picture and see what's happening. Here we have 2 more zeros, besides the one we already found. We have 2 more zeros that we weren't even really aware were going to be there. Okay, good job. Now, put your calculator away, and we are going to solve by hand problem 37 on page 83. All right, so it'll take me just a minute to get the camera set up. Sorry about the movement. Don't want anybody getting dizzy. Move this thing. But we'll do problem number 37 by hand. And then we will be done for the day. All right, here we are. Number 37, we're going to do this by hand. This is a good review problem. we already solved this, and shoot, I can't remember what the root was. You probably have it written down, so hopefully we'll match. Let's get that radical by itself. Now I know some of you like to divide by 2 before you square. It really makes absolutely no difference. If I do divide by 2, I'm going to have a fraction. So I just assume leave the 2 over there. But when I square both sides, remember you are squaring the whole side. So this will be a FOIL, x plus 1 times x plus 1. I can do that in my head because I'm ancient and I've done this and I do this for a living. If you can't, please over to the side, x plus 1 times x plus 1, and FOIL it out. Do not guess, and for Pete's sake, do not say x squared plus 1. That would be wrong. Over here we have 4 times x plus 4. So we have x squared plus 2x plus 1 equals 4x plus 16. That, my friends, is a quadratic equation. And we know, because we're going to be tested over it tomorrow, that when we have quadratic equations, we set them equal to 0. So setting this thing equal to 0 gives me this equation. Now you can solve that guy any way you want. You could complete the square, you could use the quadratic formula, or you could factor. Factoring is always fastest if it factors. This one does. So my roots are 5 and -3. But please, please remember, when you do this operation, when you square both sides of an equation, you introduce the possibility of extraneous roots. Those are roots that, while you made no mistakes, they just don't work in the problem. So you need to check your answers. And when we check them, we're going to check them in the original problem. Please do not check them anywhere but the original problem. So 5 plus 1 minus 2 times 5 plus 4. What's that equal? That's 6 minus 2 times 3. That's 0. That one's good. -3. All right, so that's -2 minus 2 times 1. Wait a minute. That is not 0. So that's an extraneous root. And I hope when we solve this on our calculator, we got one solution, and that solution was 5. All right. Have a great rest of the day. At this point, you can either begin your homework, which you do have an assignment due Wednesday. You also have an assignment due tomorrow, so if you haven't yet finished your review work, you may work on that now. Certainly you may help each other if you have questions. If you have finished the review work and you want to go ahead and get started on this, it is posted on tomorrow's lesson. It's posted on tomorrow night's homework because this homework is due Wednesday, the 1.1 homework. All right, have a great day.